Good morning, ladies and gentlemen. Welcome to the boardroom of the National Transportation Safety Board. I am Robert Sumwalt, and I'm honored to serve as the chairman of the NTSB. And joining us this morning are my colleagues on the board, Vice Chairman Bruce Landsberg, Member Earl Weiner, and Member Jennifer Hamady. Today, we meet in open session as required by the government and the Sunshine Act to consider the fatal fire on board a school bus after it ran off the road near Oakland, Iowa on December the 12th, 2017. The 74-year-old driver had entered a private driveway to pick up his first passenger of the morning, and as he routinely did, he backed up, reversed across 480th Street, the gravel road that ran past the student's rural residence. But on this morning, the driver kept reversing, and the rear wheels of the bus dropped into a drainage ditch. The bus became immobilized with its exhaust pipe wedged into the embankment. The driver attempted to regain traction and drive forward, but could not. A fire began in the engine compartment and eventually engulfing the bus. Tragically, both the driver and the 16-year-old student passenger died. On behalf of the entire NTSB, we'd like to offer our sincerest condolences to the families and friends of each of those. Clearly, the community as well has lost two of their own. Today, we will recount the facts of that day as needed. And please understand that our goal is to prevent the same thing from happening again. Statistically, and I think this is a very important point, statistically, students are safer riding to school on the bus than in a family car, and far safer than they would be with another teen driving. But when our students step on board the school bus, we should have no doubt that everything possible is being done to keep them safe. Their drivers should be medically fit, not only to operate the vehicle, but to assist in its evacuation in an emergency. Robust oversight on the part of the school district should ensure the safety of student transportation. But in Oakland, Iowa, that did not happen. Today, we will not only discuss the cause of this fire, we will also discuss the lack of an evacuation once the fire was underway. The driver had mobility challenges. Despite the fact that he held a valid medical certificate, he used a cane or a walker to walk, and he was due to have surgery 2 days after the date of the fire. After a crash, it's easy to recognize that medically unfit drivers present a hazard to passengers and to themselves. But the school district must act before a crash, when a crash is only a possibility. And in crash after crash, we have seen medically unfit drivers continuing to work past the point where their condition creates a hazard. And we see that school districts allow them to do so. The driver in Oakland had been allowed to continue driving despite the fact that the transportation supervisor, the school principal, and the driver's co-workers knew of the driver's physical impairment. Now, the Iowa Administrative Code specifies that drivers must be physically able to help ill or injured passengers, and that the employer could evaluate a driver's ability to assist in an evacuation. The Riverside Community School District, or the RCSD, had the knowledge it needed to act, and it did not. And in fact, in recent years, it had done away with the requirement for physical performance tests for drivers. It's now after the Oakland crash, so we can clearly see the need for the driver to have been medically fit. And we can see it in vivid relief how flawed or absent oversight can lead to tragic results. But school districts might still take the before viewpoint and behave as if what happened near Oakland, Iowa, will not happen to them. So here's another way to look at it for administrators. Right now, it's also before the next crash. What do you know about your drivers? What do you know about their training and their ability to perform during an emergency? What could you learn by testing your driver's ability to physically perform their duties during a drill? We will also discuss the safety of the school bus itself. Fire suppression systems, fire retardant interior materials, and improved fire safety performance standards could have provided more time for the driver and the student in this tragedy. Yet the fire safety standards for school buses have not changed significantly since 1971. That's the year that the microprocessor was invented. Now we carry computers in our pockets many times more powerful than the room-sized supercomputers of that era. But 48 years later, the federal standards for school bus fire safety haven't significantly changed. That's despite major changes in fire safety in aviation and railroad. To its credit, the school bus industry has voluntarily gone beyond the federal standards in many cases. Today, we will discuss higher federal standards that can set a single high bar for school bus fire safety, providing additional time for those who find themselves in any future school bus fire. Staff have pursued all avenues in proposing findings of probable cause and recommendations, and they will be presenting those today to the board. The order of the meeting will be that the staff will present various technical presentations, then the board members will question the staff. Our goal is to make sure that the report as we adopt it today is thorough and truly provides the best opportunity to enhance safety. The public docket for this accident, for this crash, is available on the NTSB's webpage. It contains literally hundreds and hundreds of pages of factual material, additional information including bus fire investigations, school bus driver qualifications, photos, and post-accident interviews. Once finalized, the accident report will be available on the NTSB's webpage within about 30 days. Now, Managing Director Sharon Bryson, good morning. If you'll kindly introduce the staff.
Thank you, Mr. Chairman, and good morning to the members of the board. We have a few announcements before we begin today. I'd like to request for those in the boardroom, if you've not already done so, please silence your mobile phones and any other electronic devices that you have with you. There are 2 exits in the front of the auditorium, one to my left and one to my right. Please go down the stairs in the event of an emergency, out the door, and follow the illuminated exit signs to depart the facility. You may also exit to the rear of the auditorium and proceed out the glass doors where you entered. Go up the stairs, exit straight ahead through the glass doors to the outside. Once you've exited, turn left and follow the sidewalk to the end of the street. In the event of an emergency, please walk quickly to the nearest exit and make your way to the outside following instructions from NTSB personnel. Please do not delay. Don't return to the boardroom until instructed or advised to do so. And if you have any questions or concerns, please don't hesitate to ask any of the NTSB personnel here in the room. Thank you. I would like to introduce the panel to the board that are here with us today from the Office of Highway Safety. Unless otherwise noted, the staff are from the Office of Highway Safety. Sitting immediately to my right is Dr. Rob Malloy, Director of the Office of Highway Safety. To the right of Rob is Ms. Michelle Beckjord, who's the project manager on this accident investigation. To Michelle's right is Mr. Pete Katowski, who's the investigator in charge on this accident. Mr. Dennis Collins is to his right. He is the human performance investigator. And to his right is Cheryl Harley, the survival factors investigator. And to Cheryl's right is Mr. Brian Dragonia, vehicle factors investigator. Seated directly behind me is Dr. Jeff Marcus, who is the acting director today for the Office of Safety Recommendations and Communications. To Jeff's right is Kathy Silba, who is our general counsel. Seated to the right of Kathy is Mr. Jim Ritter, who's the director of our Office of Research and Engineering. To Jim's right is Dr. Mary Pat McKay, our medical officer out of the Office of Research and Engineering. To Dr. McKay's right is Ms. Nancy McAtee, the Materials Fire Group, Office of Research and Engineering, and to Nancy's right is Ms. Julie Perot, who is the Safety Recommendation Specialist on this report. Seated immediately to the back of the room is Mr. Mark Banyard. He is helping with audio-visual, although he is our Chief of Major Investigations in the Office of Highway Safety. To his right is Dr. Lysandra Garay-Vega, who is the Chief Report Development Specialist in the Office of Highway Safety. To her right is Charlotte Cox, who is the editor on this report. To Charlotte's right is Mr. Ben Sue, who is in our Recorders Division. And to his right is Mr. Mike Laponte, who is our Motor Carrier Specialist in the Office of Highway Safety. The presentations for this report will begin with an accident overview by the investigator in charge, Mr. Pete Katowski. Pete?
Good morning, Chairman Sumwalt, Vice Chairman Landsberg, members Weiner and Hamady. Today, staff is presenting for your consideration the report of the school bus runoff roadway and fire that occurred near Oakland, Iowa. The crash occurred on December the 12th, 2017, about 6:50 a.m. Central Standard Time. As you can see in the photo, the crash occurred in a very rural agricultural area. On the west side of 480th Street, you can see the residence and driveway surrounded by brown and green fields. The 2004 65-passenger international school bus, operated by the Riverside Community School District, was traveling south on rural 480th Street outside of Oakland, Iowa. The 74-year-old bus driver was heading to his first scheduled pickup that day on 480th Street, in the area identified by the red dot as the accident location. 480th Street is a 26.5-foot wide gravel roadway and is aligned by a 2.5-foot wide earthen and gravel shoulder and a 3-foot deep drainage ditch. The speed limit is 55 miles per hour, and the average daily traffic count of the roadway is 10 vehicles per day. As was the normal practice, the driver turned right into a residential driveway for the pickup, indicated by the green arrow line. After the 16-year-old female student boarded, the driver backed out of the driveway, indicated by the red arrow line. He was intending to proceed back north on 480th Street to his next stop. Instead, the school bus continued across 480th Street until the rear wheels ran off the roadway and dropped into the 3-foot deep ditch adjacent to the roadway, indicated in the red box area. At some point, while the driver was attempting to drive the school bus out of the ditch, a fire began in the engine compartment and spread throughout the school bus. The photo here shows the bus at its final rest position. The post-fire evidence indicates that the fire likely originated in the engine's turbocharger. The exterior of the turbocharger most likely became superheated from the driver's repeated attempts to accelerate the bus out of the ditch, while its exhaust pipe was blocked. Pictured here is the accident bus, and the yellow circle highlights the location of the turbocharger. The driver and passenger died in this fire. This slide shows the on-scene staff. And this slide is a continuation of the on-scene staff. This slide lists the staff involved in the development of the report. And this slide lists the parties to the investigation. During the course of this investigation, the staff identified the following safety issues: school bus driver fitness for duty, including physical performance tests and driver oversight by the Riverside Community School District; school bus emergency training, including evacuation drills and equipment use; school bus fire safety, including fire suppression systems, fire-resistant interior materials, and federal safety performance standards. Each of these issues will be discussed in the following presentations. Mr. Collins has the next presentation on school bus driver fitness for duty.
Good morning. My presentation will discuss factors associated with the Oakland school bus driver by covering the following topics: excluded driver human performance factors, unusual activity on the driver's cell phone near the time of the crash, staff efforts to determine how the bus got into the ditch, the school bus driver's medical conditions, school bus driver fitness for duty, physical performance tests, also known as PPTs, and driver medical referrals. With respect to excluded factors, investigation determined the driver held a current commercial driver's license with the appropriate endorsements for a school bus. He had 17 years' experience, and post-crash toxicology was negative for alcohol or illicit drugs. He was operating his regular school bus on his regular route and had ample opportunity for sleep in the days preceding the crash. The driver's cell phone records showed no voice calls, but they did show messaging activity near the time of the crash. The messaging activity was not normal texting. The service provider indicated it may have been due to a third-party application. Such an application could either be active, involving driver input, or passive, running in the background. The cell phone was destroyed in the post-crash fire and could not be examined. Staff could not determine the nature of the messaging activity or when during the crash sequence it occurred. Investigators attempted to determine why the driver backed into the ditch. He was familiar with the route, the configuration of 480th Street, and the driveway where the runoff road event began. Although it was dark when the driver began to reverse out of the driveway, that condition was normal for the time of year. Moreover, the driver had regularly negotiated the driveway under similar conditions. Ultimately, staff could not determine why the driver failed to control the school bus and entered the ditch. Staff did find the driver had a number of medical conditions. Although he held a current 2-year medical examiner certificate, records from his healthcare providers document he had significant history of chronic ongoing conditions that resulted in pain in his back and both legs, stable weakness in his right lower leg, required him to use a cane or walker, and caused him pain when moving from sitting to standing. Spinal fusion surgery was scheduled for December 14th, 2 days after the crash and fire. The driver's wife told NTSB investigators that on the day of the crash, the driver's back hurt, but that he felt fine otherwise, and that his back pain on that day was not atypical. Staff looked at the driver's fitness for duty given his medical conditions. There was no evidence in the driver's medical records suggesting any of his conditions affected his ability to physically drive and operate the bus, that is, steer, use the brake and accelerator, and so on. Given the driver was found still in his seat following the crash and fire, staff then considered whether reduced mobility from his medical conditions could explain the driver's apparent inability to evacuate himself or assist his passenger. Recall that the driver's severe progressive chronic back pain caused him difficulty in standing and walking, which would have impaired his ability to evacuate the bus or help the passenger. Although the driver could board and exit the bus under normal low-stress conditions, when the driver and passenger needed to evacuate, conditions were neither normal nor low stress. The bus being in the ditch, the fire, having a student aboard, and the fire spread would have raised the driver's stress level. Staff believes the driver's pain and difficulty standing and walking impaired his ability to evacuate the school bus himself or to help the passenger evacuate the bus. Many states require school bus drivers to be able to assist passengers in distress or in case of an emergency. Physical performance tests, or PPTs, are specialized tests designed to evaluate a school bus driver's ability to physically perform the requirements of the job. Following the crash, the RCSD instituted a PPT to be administered to their drivers upon hire, annually, and as needed. A portion of that PPT is shown here. In RCSD's PPT, which is typical of those used across the country, drivers are evaluated on their ability to physically perform specific tasks. For example, drivers must climb and descend the bus steps 3 times within 30 seconds. They must repeatedly open and close the service door 3 times. And, beginning in the driver's seat, evacuate using the emergency door within 20 seconds. 6 states, shown in yellow on the map, currently require school bus drivers to complete a PPT. 10 states, shown in brown and including Iowa, allow school districts to administer the tests but do not require them. As demonstrated by this crash, school bus drivers can experience changes in their ability to physically perform the duties of their job, and these changes can occur between regular driver examinations. Given the special duties of bus drivers related to evacuation and assistance, staff believes that requiring school bus drivers to complete a PPT regularly, or when there is a concern about their abilities, enhances the safety of students and drivers alike. Staff has proposed a recommendation to the states that do not currently require a PPT to require their school bus drivers complete a PPT upon hire, annually, and as needed. The final issue area I will discuss is driver medical referrals. Coworkers of the Oakland bus driver told NTSB investigators they had observed firsthand that he had medical problems and could not walk without a cane or walker. They expressed concerns about the driver's ability to move around or control the bus. According to the Iowa Department of Transportation, IDOT, their motor vehicle division, any concerned person can submit a signed written request for an evaluation of a driver who has a physical, mental, or visual impairment, regardless of age. The requests are reviewed, and the department determines the appropriate course of action, including medical or vision tests or other examinations. It is unclear whether the Oakland driver's supervisor, his co-workers, or other school system employees who witnessed or knew of his severe impairment were aware they could refer him to IDOT for evaluation. This could point to a general lack of awareness about Iowa regulations concerning a bus driver's medical fitness and the procedures for reporting a medically unfit driver. Staff believes that awareness training for Iowa school district personnel would increase awareness of the regulations regarding commercial driver fitness and the avenues available for reporting drivers who have medical conditions that might make it unsafe for them to operate a school bus. Staff has proposed a recommendation to the state of Iowa to increase this awareness. In summary, the investigation excluded licensing, experience, drugs and alcohol, the route, the bus, and driver fatigue as factors in the crash. There was unusual cell activity on the driver's phone near the time of the crash, but the exact nature of that activity or when it occurred could not be determined. Staff could not determine why the bus entered the ditch. Staff found the driver's medical condition likely hindered his ability to evacuate and to assist his passenger. Physical performance tests increase safety by assessing the ability of school bus drivers to physically perform key functions of their job, and increased awareness of the mechanisms to report potentially unsafe drivers is needed. This concludes my presentation. Ms. Harley has the next presentation on survival factors.
Good morning. The survival factors presentation will examine the characteristics of school bus fires to include fire spread and timing. My presentation will discuss the timeline of the crash incident and the occupants of the school bus and their injuries. I will also discuss emergency egress and the onboard radio system, training provided to the bus drivers, students, and the need for training and operation of the front loading door manual door release. To illustrate fire behavior and the spread of fire through the interior of a school bus, the next group of slides will show video clips from a live school bus fire demonstration. The fire was set in the inside rear of the bus. This slide shows that at 55 seconds, the entire passenger compartment is filled with smoke. At 1 minute and 27 seconds, the non-metallic combustible materials inside the bus begin to ignite. Thick black smoke overwhelms the passenger compartment. After 3.5 minutes, the entire interior of the bus is in flames. This is the bus at the 4-minute mark. In 2017, the average response time for fire and EMS emergency personnel nationwide was 7 minutes. Therefore, anything that can be done to extend the time available for egress helps to mitigate injury and prevent fatalities. One method of mitigation is a fire suppression system. Mr. Begonia will discuss that further in his presentation. Now I will discuss the incident timeline. At 6:50 a.m., the passenger boarded the school bus at her residence. At 6:55 a.m., the driver radioed the transportation supervisor at the bus barn. The supervisor left the bus barn to drive the 11 miles to the scene of the fire. At 6:59 a.m., the uncle of the passenger called the residence and asked the mother to step outside and check on the bus. At 7:02 a.m., the secretary at the elementary school called 911. At 7:08 a.m., the transportation supervisor arrived at the scene and found the school bus engulfed in flames. As previously discussed, the driver had a pre-existing medical condition that likely prevented him from self-extricating. The mother and sister of the passenger approached the bus and found the driver still seated behind the steering wheel. The driver never attempted to stand and instead was leaning out the window and yelled to the mother to get something to break the window with. The driver sustained fatal fire-related injuries. The 16-year-old female passenger was described as healthy without any physical impairment that would have prevented her from self-extricating. At the time her mother and sister approached the school bus, the passenger was not visible, nor did she respond verbally. It is likely that the passenger had already been overcome by the toxic fumes from the burning materials inside the bus. The passenger also sustained fatal fire-related injuries. On this exemplar school bus, we can see the various points of egress that were available to the driver and the passenger. In addition to the front loading door and the rear emergency exit door, the bus had 4 emergency exit windows, 2 on each side of the bus, and 2 emergency roof hatches. However, post-fire evidence showed that none of the exits were used, even though they had been found to be operable. Staff identified a safety issue concerning the use of the onboard radio. Though this was not found to be a factor in the emergency response time to the Oakland bus fire, staff is concerned that the bus driver did not use his 911 emergency radio button. Each Riverside Community School District bus is equipped with an onboard radio installed next to the driver and easily accessible, circled here in red. The radio directly communicates with the district bus barn. The radios are also equipped with a 911 button. When depressed, the buttons connect the driver directly to the 911 dispatcher at the Pottawatomie County Sheriff's Department Emergency Communications Center. After the bus ran into the ditch and caught fire, rather than use this button to reach emergency responders, their driver radioed the bus barn. Staff has proposed a recommendation to address the need for additional training for bus drivers in using the 911 button. The next safety issue area I will discuss is in regards to the emergency evacuation training provided by the Riverside Community School District. When the Oakland fire occurred, the school district conducted emergency evacuation drills at the beginning of the school year and towards the end of the second semester with elementary and middle school students only. High school students were exempt from this training. The training was conducted by the drivers but lacked standardization and the proper documentation of the completion by the students. This training did not include how to operate the manual front loading door despite its potential use as a point of egress. The Riverside School District has made improvements in these areas. However, staff believes it is important to reiterate how vital emergency evacuation training is for all students. Staff has proposed a recommendation to the state of Iowa on educating school districts about the Oakland crash and fire, and to provide drivers with guidelines on presenting proper evacuation training to students and to document the training, that the training was completed. The last safety issue I will discuss is the operation of the manual door release mechanism for the front loading door. This photograph is a close-up of the manual door release on an exemplar bus. Arrows show all the components involved when operating the manual door. The operation of the manual door is not intuitive for someone who doesn't use it regularly. In the last 15 years, over 70,000 school buses were manufactured with manual doors. Though this was not found to be a factor in the Oakland fire, the operation of the front loading door presents a safety concern, especially in cases where bus drivers are incapacitated and students or chaperones would need to open the door. Staff has proposed a recommendation regarding the training of students and the operation of the manual door release in case of driver incapacitation. In summary, staff has identified the following safety issues. Bus drivers are inadequately trained in the proper use of the onboard radio and the emergency 911 button. Emergency evacuation training provided by the drivers was not standardized and lacked proper documentation of the training being provided to the students. No evacuation training was provided to high school students. No training is provided to students regarding the operation of the front loading door manual mechanism. This concludes my presentation. Mr. Begonia will now discuss school bus fire protection.
Good morning. In this presentation, I will discuss current federal and state interior flammability standards and specifications. In addition, I will address common areas of origin for school bus fires and how the fire spreads within the bus. Finally, I will discuss available fire suppression systems which can prevent or mitigate these fires. All school buses in the United States are required by the National Highway Traffic Safety Administration, or NHTSA, to meet Federal Motor Vehicle Safety Standard 302. Standard 302 specifies maximum burn rate requirements for materials used in the occupant compartments of motor vehicles. Since its adoption in 1971, Standard 302 has remained essentially the same, even though other transportation industry standards, such as for rail and aviation, have evolved over time with the use of more modern material flammability resistance. NHTSA has stated that it is developing improved flammability tests for motor vehicles, but these have not yet been established. According to NHTSA, states are not precluded from adopting flammability resistance specifications that impose a higher performance requirement than the federal standard for vehicles procured for a state's own use. In 1990, the National Congress on School Transportation, or NTSB, adopted a procedure for measuring flammability resistance titled the School Bus Upholstery Fire Block Test. This test mandates performance levels which exceed those required by FMVSS 302. As of January 2019, most states had adopted this testing procedure. Between 2004 and 2013, there were 3,794 school bus fires documented in the National Fire Incident Reporting System, an average of nearly one every day. When an area of origin for these fires was determined, 68% were found to have initiated in the engine or wheel area. There is a firewall separating the engine and passenger compartment. However, openings in the firewall can create pathways for fire in many instances. Due to the same stock firewall being used in many different types of buses, the firewall has multiple openings in it. Some openings allow wiring to run between the engine and the instrument panel, such as these outlined in yellow on an exemplar bus, and some openings are simply unused. These unused openings are sealed, but not with fire-resistant materials, which could prevent flames, heat, and smoke from entering the passenger compartment. Pictured here is the post-fire firewall on the Oakland bus with the same openings highlighted. In some buses, including the Oakland bus, a portion of the engine protrudes through the firewall into the passenger compartment. The firewall is cut to accommodate this portion of the engine, creating an additional route for the flames and heat to travel between the two compartments. A fiberglass cowling or housing is placed over the internal portion of the engine, highlighted here in yellow on an exemplar bus. Since it is not made of a fire-resistant material, in the event of a fire, the fiberglass cowling often contributes to the fire's fuel load as it is exposed to heat and flame. Shown in these photos is the post-fire cowling on the Oakland bus outlined in yellow. Staff has proposed a recommendation that buses with engines extending into the passenger compartment be equipped with fire-resistant materials and firewalls to create barriers against flame and smoke. Additionally, to prevent the spread of fire from the engine compartment to the passenger compartment, some buses are equipped with an automatic fire suppression system, or AFSS. Most automatic fire suppression systems deliver a fire suppressant inside a vehicle's engine compartment when a fire sensor is activated. These systems use either thermal sensors to detect heat or optical sensors to detect flame on specific ignition points or flammable agents on or near the engine block. The system then alerts the driver and automatically releases a water mist or chemical powder suppressant. With some systems, the bus does not need to be running or have electrical input for them to activate. Pictured here is an example of a thermal automatic fire suppression system. Several spray nozzles located in the engine compartment of a commercial vehicle are highlighted in blue. These systems can be installed in buses during or just after new manufacture or placed into buses already in service. No national standards exist for the installation or performance of an automatic fire suppression system. However, specifications have been defined for testing these systems, as well as voluntary performance certification, both in the United States and internationally. Staff has proposed a recommendation that all newly manufactured school buses be equipped with a fire suppression system. Several states now allow for installing suppression systems in school buses as optional equipment. Some require suppression systems on alternative fuel vehicles, while other states require a suppression system on buses that transport special needs students. Most of those states have adopted the following national school transportation specifications and procedures for a suppression system installed in a school bus. These specifications are: fire suppression system nozzles may be located in the engine compartment, under the bus, in the electrical panel, or under the dash, but they may not be placed in the passenger compartment. They must include a lamp or buzzer to alert the driver that the system has been activated, and alternate fuel buses may be equipped with an automatic or manual fire detection and suppression system using interior or exterior detection. In summary, even though new fire-resistant materials have been developed and used in transportation modes such as aviation and rail, the federal flammability standards for school buses have not changed in nearly 50 years. These fire-resistant materials can slow the spread of fire, heat, and smoke through the school bus. New buses can be equipped with the automatic fire suppression systems, and the same systems can be installed on older buses already in use. These can prevent or mitigate many school bus fires. This concludes my presentation. Staff is available for any questions you may have.
I want to thank staff for those very good presentations and also for a very thorough and comprehensive investigation. We'll now go to the board member questions, beginning with Vice Chairman Landsberg.
Thank you, Mr. Chairman. Roughly, am I understanding correctly, we're having one school bus fire a day? And how long has this been going on?
That is correct, and the statistics we have, it's been for decades, but the reference material that we have, it's been documented for the last 10 years.
So how are the school districts and bus manufacturers addressing this? I mean, this doesn't seem at all like it's an isolated problem. And also, do we have any data? I mean, here we have a particular case where a turbocharger overheated because of the tailpipe being blocked. But what's causing all of this, and what's the industry doing to fix it?
The causes for the fire vary. Obviously, we have, in this particular instance, we have a turbocharger incident. Sometimes they occur in the wheel wells when something gets caught in the wheel well and overheats, or a wheel bearing or something like that. So there's obviously many causes for the fires. As far as what the school districts are doing, some of them have decided that the way to go is installing the fire suppression systems. We do have more and more of those being put in nationwide, and that's one of the reasons that we've decided to make that recommendation. We feel that if it's being implemented anyway, that it's a good idea to make it a mandatory nationwide, especially for new manufactured buses. And then, sometimes it's the age of the bus that's the issue, and so some school districts will limit the amount of years that the school bus can be used in their districts, and in an attempt to kind of mitigate some of the fire issues.
How difficult is it to do a retrofit? It sounds like, depending on the school district and their funding, that the age of the bus obviously is going to be a concern, and they're going to run it as long as they can. And does that increase the risk?
It does somewhat increase the risk, because as those hoses and materials in the engine compartment age, they're going to be more prone to bursting. As far as your question regarding the retrofitting of fire suppression systems, I'm not familiar with all of the different systems, but the ones that I am familiar with, it does appear that it is not necessarily an extremely labor-intensive process. It's something that can be done within just a few hours on most buses. And obviously, the decision to make a retrofit would, as you pointed out, depend on the age of the bus and the funding available.
In terms of the age of the bus, this was a 2004 bus. Is that a middle-aged bus, an old bus? How does that fit in the grand scheme of things?
It truly does depend on the school district. We have school districts out there that are running 20-year-old buses. Some states mandate a 10-year lifespan. So once again, going back to the funding available for the school district and the replacement cycle of the buses, it is not unusual for a 2004 school bus to be operating, however.
One thing that seems to jump out here is the fact that the firewall didn't really prevent much fire from getting through from the engine compartment due to some of the factors that you cited. The fiberglass enclosure that was used to cover the back end of the engine, how effective would that have been in providing them with more time to exit, and how much time does one have once a fire starts before the firewall might potentially fail?
I believe that would truly depend on the specific fire ignition point or the area of origin as far as the timing is concerned. It is, however, staff's belief that using a more fire-resistant covering or cowling on that portion of the engine would extend the amount of time available for evacuation, and that's one of the reasons that we've decided to.
Is there any standard for the amount of time that a firewall should perform its function?
I'm not aware of any standard.
Thank you.
Thank you very much, Vice Chairman. Member Weiner.
Thank you, Mr. Chairman. The bus arrived at 6:50 to pick up the passenger, and this was a typical or usual process to back out in the dark. Is that correct?
It was the normal practice to back out of the driveway, yes, sir.
And why not continue it through the loop that was shown on the photograph?
It is our understanding that the homeowner requested that the driver not do that due to concerns over damage to the driveway and other property issues. So the driver made the decision then to reverse.
In this particular accident, we have some concern for the driver mobility. How was the driver certified, or who certified the driver because we didn't have a physical performance test? So what kind of certification process was there that the driver was medically fit for this service?
He was required to complete the medical examination process for commercial drivers as specified both by the state and federally. The typical normal commercial driver examination.
So we're dependent on the medical professional to assess the suitability of the individual to operate a school bus. Is that correct?
Yes, sir.
Are we perhaps asking too much from a medical professional that he or she understands what the requirements are for operating a vehicle?
I'll defer that to Dr. McKay.
So the standards from the physician standpoint or the healthcare practitioner standpoint, who's a certified medical examiner, the standards for a truck driver and a school bus driver are not necessarily different in terms of the CDL medical exam. The additional physical requirements for the school bus driver related to assisting in evacuation are specific only to school bus drivers, and typically the oversight for those is provided by the school system.
So there are separate criteria for school bus drivers. Did I understand that correctly?
That's correct.
Okay. When we talk about the pickup and the requirement that the bus back to the road in the dark, is there any process to do a risk assessment from the point of view of what makes sense? Because we've had other accidents where children were killed crossing a road, basically a high-risk activity. So is there a risk assessment process for school bus routing?
We'll have Mr. LaPonte answer that question.
The risk assessment would vary by school district as to whether or not they would make a risk assessment based on the route. Our investigation indicated that these routes were basically designed by the drivers based on the addresses of the students. So there was not a formal risk assessment taken prior to actually setting up these routes for the school bus drivers to operate.
So the bus drivers made the risk assessment. Was there any training or familiarization, at least, on the part of making sure the bus driver was really well-equipped to assess the risk?
The training consists primarily of the state of Iowa has annual training as well as initial training for school bus drivers. And part of that training is to read the driver's manual and so forth and assess what is the safest practice for picking up and dropping off the students. It was felt that driving into the driveway was safer than sitting on the road in this situation because of the weather and the distance to the roadway and so forth. And the driver had performed the backup of this particular pickup for many, many years. He had been picking up this student at this location for many years. So it was not an unfamiliar process for him to back out of the driveway.
Thank you.
Thank you, Member Weiner. Member Hamady.
Thank you, and thank you for all your work on the investigation and also this report. I do want to stress that school buses are still the safest way to transport children to school, but when an incident does occur, it's important to understand how it happened and to determine what actions are needed to prevent it from happening again. I want to circle back to a question that the Vice Chairman asked, which is about the number of fires that occur. And I think I saw in the research about 1.2 a day, but are school bus fires required to be reported to states or the federal government?
School bus accidents reporting varies by state. So for instance, the state of Delaware reports every accident that happens to include a fender bender in a schoolyard where the mirror would be knocked off. Some states do not have that requirement. That being said, it would also then, to be reported to the federal government, have to be a DOT reportable accident, which many of these situations are not. So there's not really a central database that one can look at to get all this information.
So that leads me to the question, is the 1.2, could that be underreported?
It's certainly a possibility, ma'am.
Thank you. And should fires be reported to either the state or the federal government so there's a better understanding of how many actually occur?
I believe that a lot of the data that was gathered by the Volpe report that is referenced in the report, the NTSB report, they were sourcing their numbers through the National Fire Incident Reporting System, and also I believe they pulled some additional information from insurance statistics, because obviously after a fire, a lot of the school districts will submit a claim to their insurance companies for the cost of the fire as well. So,
thank you. This investigation, our 1988 investigation of a collision between a pickup truck and a church activity bus in Carrollton, Kentucky, identified concerns with Federal Motor Vehicle Safety Standard 302, which deals with the flammability of interior materials for buses and other motor vehicles. As the chairman stated, that standard was adopted in 1971 and hasn't changed much since then. In fact, NHTSA at an SAE government industry meeting in 2017 said, while some of the other transportation industry standards for aircraft and rail have evolved over time with the use of more modern material flammability techniques, FMV SS number 302 has remained essentially the same since 1972. So our report talks about how the standard is outdated and inadequate. Can you elaborate on that?
In addition to an improvement in material flammability, there's also an improvement in testing. In other modes of transportation, the testing tends to be more accurate of an actual event, not just a lab test. So it would be twofold if they were to update the standard.
Okay, and since our 1988 investigation, the National Congress on School Transportation has developed a more stringent flammability standard called the School Bus Seat Upholstery Fire Block Test. Can you describe the difference between that standard and 302? Anyone?
In our appendix at the end of the report, we list out what the differences are. It's a more robust but a slightly different type of test. 302 was premised on a cigarette sitting on an upholstered seat. The fire block test actually places more material closer into the seats and then ignites them with different methodology rather than just a cigarette. And so it's definitely a more robust test. And as we talked about in Brian's presentation, the states went ahead the school districts went ahead and adopted these through their states because they felt it was more robust than 302 was. And so they're using that when determining what type of seat coverings to put inside the school buses.
And do you know how many states require their school buses to adhere to that more stringent standard? And is it a requirement?
It's a fire block test that the National Congress sets guidelines and standards that if states choose to adopt them, they can hold where they can go in and say the entire state has decided all school buses just meets what that Congress has put forward. So in this case, it's updated every 5 years. So in 2015 was the latest update, and we expect the next one to come in 2020. Some states will go in and say, we are going to state that every bus just meets everything in it, or they will actually go in and customize and decide for every chassis, every seat, every add-on, standard or optional for their buses. They may go in and choose a different requirement than what the national standards are. But others, like I said, will adopt it wholeheartedly. I have an entire spreadsheet that I can provide to you later, but most states have adopted what the National Congress has put forward. I would say there's more that have done that than have gone in and every now and then made a change, but on the whole, they've adopted it.
Thank you.
Thank you, Member Hamady. If we could pull up slide number 33, please, Mr. Banyard. I think the question that everyone has had through this tragedy is, why could the 16-year-old passenger not get off the bus? And I think we've explained why the driver could not due to his immobility. But when I looked at this slide and also read footnote 98 of the report, it sort of clicked with me. I envisioned that this handle was, and I guess this will be for Ms. Harley, but I envisioned this handle was sort of a cam, a lockover cam that you just, with enough force, you can pull. But it's a lot more complex than that. And I saw you getting coffee this morning, and I asked you about this. So could you explain, the word that you used when you described it this morning in our presentation was that this is not intuitive. So talk about this handle, if you would, please, and how we open the door.
Yes, sir. So staff is providing the same slide, but it has the labels of the components that are involved in operating of the door. So in order to actually open the door, the first thing that a person has to do is to reach under the door handle control latch. It's a spring latch there. They reach underneath that latch, and then they have to lift it up, which allows them to have access to the door control knob. Once they get a hold of the door control knob has a sliding collar on it. That collar has to be slid upward in order to unlatch it from the keeper that locks it into place. Once you slide it up, you have to keep it held upward, and then you have to pull the handle out. And then you pull it away and push it away from you. At that particular point, the lever arm exerts pressure against the left door, and the left door pushes open the right door at the same time.
Not nearly as easy as I thought. And in looking at that picture, and maybe I'm wrong here, but it looks like this, I've sort of envisioned this door handle as being out in the position that it is now, but that's when it's open, it's sort of out in that area. But when the door is closed and secured under the door handle control latch, is that handle maybe just more or less above the driver's right thigh or knee? Is it sort of, that's sort of what it looks like it could be for me. How far back is that?
It is actually adjacent to the driver's right leg, that's correct.
Yes. So it's not intuitive, and certainly in literally the heat of a battle, in an emergency situation, if you've never operated that door before, and you're standing in the aisle or crouch down in the aisle, how easy would it be to try and open that door?
If you are not trained on how that door operates, it would be very difficult for you, especially in an emergency situation, for you to open that door. And that was the reason we had proposed a recommendation about the students needing to have the training, so that they would know how to open the door in the event that their driver is incapacitated and could not help them.
And then you add the possible panic factor. I don't talk about this often, but I've said it before in a board meeting. When I was 20, I had to get out of an airplane that was on fire, and I went back to the emergency exit and socked it. And they won't open if you do that. You have to actually know how to operate it. Fortunately, somebody behind me was able to open a door and we got out. But under the panic, I can understand now, after you're describing this and the panic and the time pressure, I can understand how this door would not have been opened, as we all wondered. Let's talk a little bit. I tell you what, I'm just going to yield the balance of my time. I want to get into the oversight by the school district, but I don't want to do that in 52 seconds. So we'll go to the next round, Vice Chairman.
Thank you, Mr. Chairman. You said, showing from the pictures of the, once a fire gets started, that there isn't a lot of time to escape. And in the exemplar situation, in about 2 minutes, the bus was filled, the exemplar bus was filled with dark smoke. Do we have any sense of how long it takes for somebody to become incapacitated with smoke and this sort of circumstance?
It really depends entirely on the components of the smoke and how much smoke is in the bus. We certainly have experiences or seen somebody who's crawling along at ground level the way that you were trained to deal with a fire, who stands up to accomplish some task and is very quickly overcome simply by standing up into the much thicker smoke at the top of the structure or the vehicle. So it can happen very quickly.
In terms of the testing, so it sounds like even though there's not a federal requirement that has been updated since 1971, that the industry has sort of established a better situation. How good is the testing on this? Because, you know, a cigarette burn is laughably inadequate when you're talking about a major fire event.
Can you repeat your question or clarify it for me? What do you mean by?
Yeah, I'm just curious as to how good the testing is. Current requirements for testing for flammability.
The board has gone on record in previous reports, particularly the Oakland, California report that we put out a few years ago, in which a motor coach caught on fire and we lost several high school students that were in a charter trip. And in that report, we stated that we felt 302 was not robust enough, that we felt there was dramatic improvements that could be made, and we made the recommendation to NTSB that we felt they needed to go back and improve that performance standard significantly. And so we have a recommendation that, and NTSB is making some progress. They have started testing, including on school bus seating components as part of that testing, to develop new and improved performance standards that upholsteries and interior materials need to meet.
But it hasn't been implemented yet, is that
Not
correct?
yet.
Okay. Going on to driver fitness, apparently, if I remember correctly in the report, it said that the Riverside school system did have a requirement for the bus drivers to pass an annual fitness and ability test. Do we have any sense as to why they dropped that?
They dropped that test in 2011 due to the fact that the transportation director had changed, and the new transportation director did not continue those tests after that point in time. We asked that question specifically, and that was the answer we were given.
And the answer was?
Well, the answer was that the new transportation director didn't continue the tests, and they were not, continued going forward. Now, is that the only reason? We don't know that for sure, but I think there could be other reasons that helped in that decision-making by the school board in the state of Iowa at that point in time.
Is there an industry standard for school bus driver fitness nationwide, or is this sort of left up to the individual school districts?
Right now, there is a standard that they have to pass a CDL medical, which will look at generally medical conditions that might make it hard for them to drive. With regard to performing their emergency duties, we think the PPT the performance test is important, and that's why we're recommending that across the nation, school bus drivers will be required to do that PPT.
Okay, so that doesn't exist now, though?
No, that's why we're making the recommendation.
Okay, all right, very good. No further questions.
Thank you, Vice Chairman. Member Weiner.
So we've talked about interior materials and the amount of time that they have to get off the school bus. Is there a defined process for the driver in terms of how to handle a fire emergency?
In the Oakland crash, the driver's handbook was quite clear that if there is any indication of a fire, that you would immediately evacuate the bus. That's in Oakland specifically, in that driver's handbook.
So it is a set process for the driver to basically get off the bus and evacuate all the students.
Yes.
What kind of training does the bus driver have in evacuating students?
The training that is required is the emergency evacuation drill. And the emergency evacuation drill is provided to students, but deals with students being able to utilize the emergency exits. The front loading door is not considered an emergency exit, even though it certainly can be used as a point of egress in an emergency. And that was one of the reasons we made the proposal, that the students need to know how to operate that door to get out of it. But the emergency evacuation drill is the training that is provided for any situation where they have to evacuate a bus. That also includes fire.
So that's training for the students, but what I'm concerned about is training for the bus drivers, because they become trainers for the students, correct?
That is correct. The bus drivers provide the training to the students.
So in case of fire, the process was to immediately evacuate the students. The fellow aviators here on the dais will recognize the order: aviate, navigate, and then communicate. Aviate meaning fly the airplane first. Navigate, figure out what to do, where to go. And then finally, communicate. In this case, that seemed to be reversed. In fact, several minutes went by. Well, the fire, or between the time that the bus went into the ditch and the call to the communication back to the bus barn. Is that correct?
There was a 5-minute period from the time that we know that the student boarded the bus to the time that the driver actually communicated that he was in trouble to the supervisor at the bus barn.
So do we have any idea what was going on during that 5-minute interval?
No, sir, we do not.
When he called for assistance, did he actually report that he and a passenger were stuck inside?
The driver
I guess what was the nature of that communication with the bus barn?
The driver relayed that the bus was in a ditch, the bus was on fire, and that he couldn't get out.
So he was really close to the point or past the point of being overcome by smoke?
I couldn't speculate on that, sir.
Mr. Chairman, I think I'll yield the balance of my time.
Thank you, Member Weiner. Member Hamady.
Thank you. A lot of the questions I'm going to ask now is information in the report, but for the benefit of those that are attending or watching, I want to ask these questions. How many school buses are on the road right now? What's the fleet, generally?
The data that I have from the American School Bus Council indicates that there are about 480,000 school buses on the road today.
Okay. I think our report also mentions maybe 600,000, I'm not sure. But how many children can a school bus carry?
That would depend obviously on the size of the school bus.
There are 4 types of school buses, so probably about 10 to 90, depending on what type of school bus. And then how many children ride school buses to school annually in the U.S.?
About 26 million a day.
26, oh, a day, okay. And we know that the average operational lifespan, I guess, from the school bus industry, they say average age is about 9 years, and average retirement age is about 14 to 15 years. Is that correct? Mr. Katowski, or?
I believe that would be correct. As I stated before, we have some that are retiring after 10 years as mandated by state regulations in some places, and then some places where they're operating into the 20-year range.
And where do most fires originate in a school bus?
68% originate either in the engine compartment or the wheel well areas.
Okay. And the Oakland school bus wasn't equipped with an automatic fire suppression system, is that accurate?
That is accurate.
And why are fire suppression systems helpful? And I'm going to turn to Ms. Harley on this one because you stated, and remind me of the quote, anything that can be done to extend the time for passenger egress. You had mentioned that.
So a fire suppression system has several functions. First is to detect the fire. Second is going to be to suppress it. And third, of course, is going to be to prevent the reignition of it. And certainly, detecting the fire early and being able to suppress it will certainly extend the amount of time that someone will have to egress a vehicle that's on fire.
Thank you. Several states allow installing an automatic fire suppression system as optional equipment. Do any states require it?
Many states require it for special needs or alternate fueled vehicles. Almost all of them do. You then have it as optional for the regular school bus fleet. And automatic fire suppression systems are also required on transit vehicles, and a lot of school systems would also either permit and or use that system, a transit bus, to get their students to school, primarily city schools. So you'll have some students on buses where it's required and some not.
And is it possible to install a fire suppression system on an existing school bus?
Yes, it is.
And our report recommends the installation of automatic fire suppression systems on newly manufactured buses. Why not the existing fleet? We just learned 26 million kids a day, 600,000 buses. Why not the existing fleet?
One thing is, we certainly know it can be done because we've talked to the manufacturers of the systems, and they have done retrofits. One of the difficulties is when we've made recommendations in the past for retrofits, we've rarely been successful. The only example I can think of for our success was retrofitting of striping on tractor trailers. We have asked for it when there are basic components that are available. So we did ask for a retrofit on rollover prevention devices on trailers that had anti-lock brakes, because that was just an add-on that could be added. We have seen some discussion of retrofit for speed limiters, because a lot of vehicles have speed limiters already that just would then set that. But we've never seen a retrofit for a brand-new system that wasn't building upon another.
Okay, and we did have a presentation by at least one manufacturer yesterday that talked about both retrofit. In fact, I think 90% of what they did was after market, after delivery. Granted, most of those were new, but they also did retrofits. And it generally took, at least what was reported, about the same amount of time, a kit, and maybe some different parts, but generally still about the same cost as a newly manufactured vehicle.
And let me just say that staff agrees with you wholeheartedly that retrofits are a good thing, and we're glad that companies are taking that route, and we're hopeful this report will help other companies take that route. We just believe that a recommendation to a federal regulation would just likely not succeed, so we're not taking that route.
Thank you.
Thank you, Member Hamady. Regarding the oversight responsibility of the school district. So what responsibility does a school district have to provide effective oversight over its drivers, including medical fitness? And I'm sorry I didn't direct that to somebody in general, but specifically, but who can answer that one?
So with regard to the fitness, again, they go through a hiring process to hire drivers. They're required to make sure that they've got a CDL with medical that's valid. They do that. They're also a requirement that drivers are fit to do their duty each day. With regard to seeing drivers who are unfit, we've seen this in other school bus cases. Baltimore, Chattanooga, we made a recommendation to improve the reporting of drivers who become unfit and are not willing to take themselves off duty by other transportation officials. And we see the same thing in this, where there were people as part of the school district who were aware of his medical issues that had developed, had not taken action that they could have. And so we've made a recommendation to require them to do so.
Well, thank you. And I want to put a fine point on this. The school district has a responsibility to provide proper oversight, and I'm going to read out of page 67 of the draft report. The RCSD had a responsibility to exercise effective driver oversight that would ensure both the medical fitness and the physical ability of a driver to perform the task associated with normal or emergency operation of a school bus. Did they fulfill that responsibility? Yes or no?
They did not.
Okay, thank you. Did they have a policy? Did the school district have a policy that allowed the administration to require a driver to submit for additional examinations if the school administrators deemed that their physical or mental health might be in doubt?
Yes, they did have a policy for that.
And as you've stated, the principal of the school and I stated this in the opening statement, the principal and the transportation supervisor both were aware of this driver's physical impairment. And did they exercise their ability to submit that driver for additional examinations?
Mr. Chairman, they did not.
So we talked about physical performance tests. we know that we have these things called discrimination, and you can't discriminate against people with disabilities. And we're not talking about discrimination, are we? We're talking about keeping people who are not medically fit from driving a school bus full of children. Is that what we're talking about?
That is correct, sir.
But from a legal point of view, what legal aspects could the school or the school district have to say we're going to require a physical performance test? We were talking about this a few days ago. We as a federal agency can't say, well, you can't come to work here if you can't do certain things. So what legal point of view would a school district have to keep someone from driving?
I think one of the things that we had looked at was whether or not, it's not a question, if the driver had passed his FMCSA required medical examination. In this particular case, as well as what we had seen in previous cases, this was an acute situation where he had a mobility issue that the school system in the past had used their physical performance tests for exactly this situation, in that it didn't appear that he could perform his emergency duties, and those emergency duties are vital to his job as a school bus driver. We're not saying that he would be forever removed, but at this particular point in time, it was an acute situation that the school district, had they followed their policy already in place, would have been able to say, at this particular time, you're not able to perform those emergency duties. We've given you that physical performance test that's part of the job. And as a result of that, until you're able to return to do the emergency duties that are part of that physical performance test, we're going to have to give you a different position or not have you driving until you can come back and pass that. And so they had already been doing that previously. And so our recommendations are that they do that again, and Riverside has reinstituted those physical performance tests, and we are asking the state of Iowa, along with the other states that Dennis Mr. Collins had shown in his slide, that don't currently require physical performance tests, that this is an idea that they should explore and that we are recommending that they do so. And perhaps they could look at the states that do require it as a best practice or a guideline for developing one for their own state.
Well, thanks. In fact, I know I'm out of time, but I just want to finish this point, and that is that in fact the Iowa Administrative Code does specify that a school bus driver must have sufficient physical capability to render assistance to the passengers in case of illness or injury. And the code also allows employers to be able to evaluate an applicant's ability in operating a school bus, including all safety equipment, in providing assistance to passengers in the evacuation of a school bus. So the code, the law, the Iowa law, is covering the school district to make sure that they can do what they need to do. But as we said, in this particular case, the school district did not do what they needed to do. Thank you. We can go to the third round, or we can take a break now. Okay, we'll take a break. We'll be back at 10 after 11. We are in recess. Okay, we are back in session, and we'll begin with the next round of questions. Vice Chairman Landsberg.
Thank you, Mr. Chairman. Given what I've learned today about the significant number of bus fires that we seem to have annually and our apparent inability to contain them within the engine compartment, which still surprises me, but are we getting adequate training to the bus drivers and by the school districts to cope with what seems to be a fairly regular occurrence of fire, what to do about it, how to evacuate, and sort of keying off on Member Wayner's comment, in the aviation world, we practice and train these things pretty regularly, and the first thing is if you got a fire, let's do something about it really fast because it's a bad thing. So, general question, how well are the school districts preparing their drivers and their students for what almost seems like an inevitability of fire? And that's a whole nother discussion.
Again, as far as the students are concerned, the emergency evacuation drill is the only training they receive in regards to evacuating a school bus. As far as and that training, of course, is given by the drivers. The extent of that training depends on each individual driver because there doesn't seem to be, at least in Riverside Community School District, a standardization as far as that training was concerned. And that was the reason behind our proposed recommendation about that. As far as the training of the actual drivers to give the training to the students, that's something I would probably refer to Mr. LaPonte as far as his contact with the school district as far as training their drivers.
So there's no ability to monitor how effective it is, and is there any testing that's done to see? That's the sort of the trust but verify. We've got a requirement here, but we never test anybody?
The issue that we found in the Riverside Community School District was that there wasn't any documentation, and the documentation didn't go through exactly what kind of training and the extent of training that was given to each student. It was just a driver saying, we gave training.
Okay, and to echo the chairman's comment, it's far better to have a hands-on experience, which the students would actually be manipulating the doors, the windows, as opposed to being told, this is how this works. You all remember it in case of an emergency. No further questions, Mr. Chairman.
Thank you very much, Vice Chairman. Member Wayner.
We've had a lot of discussion about actually flammability materials, and we've had other discussions over the years about the efficacy of preventing so that you don't have to worry about survivability issues to the same extent. Have we looked at preventing bus fires? Are there measures that could be taken or could be suggested or recommended to prevent bus fires?
I think one of the things that we recognize in the school bus industry is that school buses are running, multiple times a day, often in very difficult situations, like, for example, in the Oakland fire, you had the school bus that was going up and down for many miles on gravel roads. School buses are driven hard. And so one of the things that needs to be recognized is that you do have maintenance that needs to be done, and there are scheduled maintenance intervals that are done by proper transportation departments. So you're never going to be able to completely prevent the fire in locations like the engine where you have chafing of the wires and you have other components that run very hot in the engine and that kind of thing. What we've seen so far is that when these fires do occur, the systems that are out there for mitigation is where we can prevent the fire from going any farther. Some of the automatic fire suppression systems can literally put the fire out within seconds and then continue to keep it from reflashing. And that's what we have found between that and also being able to fireproof the firewall openings, because you need to have the openings for the engine components to go into the driver's dashboard area. That's just part of the way the bus is designed. It's also part of the way that small airplanes are designed. You have the firewall, but you have to have a component come through it. But in what we were comparing to the firewall being incomplete is you have abilities to institute fireproof materials to seal those openings. So if you have the majority of your fires occurring in the engine, which likely they're going to continue to occur, how do you then maintain a safe environment? And so we've proposed the fire suppression system so that if there is a fire, the bus driver can pull the bus over and has enough time to get the students off. And if there is a firewall that doesn't have any openings to it, that is another amount of time provided for students to get off. Now, we have been reporting that there's been at least 1.2 fires a day, and we have school bus drivers that are doing extraordinarily well to get their students off. But what we are concerned about is that the more time, the better the evacuation can be. And so that's why we're looking at, you're never going to prevent all fires, but what you can do is if the fire does occur, to quickly put it out and to keep it from reflashing. And that's why we are recommending the automated fire suppression systems and the better firewall components.
Okay, thank you for that rather complete answer. Let me move to a different subject. In the Crozet accident, the Amtrak congressional special about a year and a half ago, we encountered a commercial driver who was taking the drug gabapentin, and understand that gabapentin has increased use considerably in the last 15 years. It was originally intended, or its intended use is for epilepsy, but it's used off-label, in some cases for chronic pain. There is apparently not a great deal of literature about what the side effects are and what the potentially impairing effects are. So, Dr. McKay, could you comment on that?
So there's actually a fair amount of literature on gabapentin. Somewhere between 20 and 40% of people, when they initially begin to take it, will have side effects such as somnolence or dizziness, other psychoactive side effects. With use, many of those side effects dissipate over time. In this case, this individual had been on gabapentin for many years. He was observed the day before this accident by his supervisor while performing his duties, and was not seen to be impaired or have difficulty performing his duties. Therefore, we did not think that his use of gabapentin was impairing at the time of the accident.
Okay, so gabapentin had nothing to do. One last question. This was fairly low-speed impact. Was there any potential for structural damage to the point where doors were unable to be opened because of structural impacts?
No, in this particular crash, there wouldn't have been enough body damage or induced damage or any contact damage that would have affected any of the doors, any of the emergency doors or the main boarding door.
And the impacts were small enough in terms of forces to not exacerbate his medical condition?
There was no evidence that he had any injury related to the falling of the wheels into the ditch.
Very good, thank you.
Thank you, Member Weiner. Member Hamady.
How long did it take for the fire department to arrive on scene?
The fire department, I believe the first unit that arrived on the scene was approximately 20 minutes.
And it's not unusual for a rural area where that would occur.
No, ma'am, it's not.
Okay, which I think, from my standpoint, and I would assume from others, that that just underscores the importance of adequate emergency training and firewall protection and a standard for the flammability of interior materials. In 2003, NHTSA terminated the rulemaking process to upgrade the flammability standard for school buses. Do we know why?
In 2003, part of the reason, we had made a recommendation to NHTSA previously to improve FMVSS 302 in totality because we felt the flammability standard was not up to par. What the agency had done was go back and forth and determine that they felt that an increase, particularly right after the Carrollton fire, was that an increase in the number of emergency exits was a better alternative than to do anything with the flammability testing. So they felt that by adding the doors or adding more other exits on school buses was the answer to the recommendation that we made in Carrollton. We felt that that wasn't adequate, and while they stopped their testing in 2003, they never picked it back up again, which is why we felt that in the Orland motor coach crash and fire that they needed to revisit FMVSS 302, and we issued that recommendation to them again, that they needed to go back and start doing better testing and better performance standards.
So in aviation and rail, there are more stringent standards. And can you talk about the difference?
I'd like Ms. McAtee, who's more familiar with
Sure.
aviation and rail.
Both aviation and rail focus on flammability or flame resistance, smoke, and toxicity. They're both very similar in that they have, for instance, flame can only spread for a certain length across a surface, for like a seat cushion, for instance, up a sidewall, things like that. Mostly, particularly in aviation, the key there is there's nowhere to evacuate to. So you have to be able to give time to be able to get that aircraft down on the ground. Rail, just because aviation had these standards, they had several incidents where they had fires in transit rail, particularly. The test methods were already out there, the materials were already out there. It was just easier to adapt those to the rail industry. So that's kind of how rail mirrors aviation in a lot of ways when it comes to the flammability and smoke and toxicity of the materials inside of a passenger area.
Can you talk about what NHTSA is doing now? Because I'm just trying to understand what takes so long, since everybody says this is an inadequate standard. Even by NHTSA's own admission, it's inadequate, and it dates back to 1971. So I'm just trying to figure out what is going on at NHTSA.
I think in this case, again, staff believes that there have been standards developed in the other modes, that this is not developing a brand-new standard, and it is more of a lack of will to move this forward.
Thank you.
Thank you, Member Hamady. I want to follow up on the issue of the ability to or inability to escape from the bus. And so I did get into the questions about the door handle for the loading door. And Ms. Harley, when I saw you and Mr. LaPonte this morning down getting coffee, there was a question about, I think there was a statement about the angle that the bus was in the ditch. So even, I mean, could that door have been, if the lever handle could have been operated, would the door still have been jammed?
So one of the problems that we had was that the door was consumed in the fire, so there was actually no door. The bus was lowered to the ground, but that was also could have been caused by the fact that the tires were now no longer inflated. At that particular point, we really couldn't do any additional testing to determine whether or not the door had been jammed from any kind of external force.
Thank you. And to be clear, was there any evidence that any of the other exits on the bus had been attempted to be used?
No, sir.
Thank you very much. We've talked about fire suppression systems, and as I understand it, the temperature of this turbocharger that we believe is what led to the fire. The temperature inside a turbocharger is between about 1,000 and 1,200 degrees. And so could a fire suppression system, we're not saying that the fire was that hot, but I guess, Ms. McAtee, this may be for you. Could a fire suppression system accommodate a fire of that temperature? And I guess if nothing else, it could beat it down to prevent the spread of it, but I'd like for you to talk about that, please.
It absolutely can. That's one of the factors that most of the suppression systems out there address, or one type, particularly water. They address that not only that they remove one of the legs of the fire triangle, and one of that is heat, and it's an easy way to mitigate a fire.
Great, thank you very much. I noticed that there was a NTSB study, and I'm not sure, again, maybe Ms. Beck-Jordan, I don't know who would take this. There was a NTSB study that was announced in 2017 titled Test Procedures for Evaluating Flammability of Interior Materials. What's the status of that NTSB study?
NHTSA contracted with the Southwest Research Institute, and Southwest Research Institute recently, just in April of this year, gave a status update on their testing methodology, what they're currently using to test various components. Now, 302 applies to all motor vehicles. So it's anything from the cab of a tractor trailer to a two-door coupe to a school bus to a motor coach. So it encompasses all vehicles. And so what they're doing is looking at all the materials used in all the vehicles, and then they're also looking at all the types of testing that's out there. For example, what might be used in aviation or rail, and they're trying to figure out which methodology would be the best standard to use for all the vehicles that they're testing for. Part of that they just reported on is that they're involving at least some components of the interior of a school bus. So Southwest Research Institute is anticipated to release more of their testing later this summer into next year. The final study from NHTSA, we're not sure. That it was supposed to be released in June of 2018, but as I just stated, they're still continuing to conduct what type of test they want to do. And so we're waiting anxiously for Southwest Research Institute's final report to come forward via NHTSA.
Thank you. Mr. Marcus, coming out of our SIR on select school bus safety issues that was issued in May of last year, we issued recommendation H 18-16. And you have an encyclopedic memory, but if you need, do you recall what that recommendation is?
I think Ms. Perot may be in a better position to answer that.
Of course, thank you. Sorry, Ms. Perot.
No problem. It was a recommendation to various school bus organizations to inform their members about medical reporting.
Yes, and I noticed that there's one organization that has not replied to us yet, the American School Bus Council. What's the status of that?
According to what we've discussed with NAPT, NSTA, and NASDIPS, my understanding is that the American School Bus Council is actually a separate group. It's composed of some of these other groups, and so perhaps we shouldn't have issued a recommendation to the American School Bus Council because the other groups are already taking care of it. But that's something that we need to discuss a little bit further amongst staff after this meeting.
Okay, very good, thanks. Further questions? No further questions? Ms. Bryson, if you'd please read the proposed findings.
Yes, sir. The findings, as a result of this investigation, staff proposes 18 findings. Finding number 1, none of the following were factors in the crash. A, school bus mechanical condition. B, driver licensing, experience, alcohol or other illicit drug impairment, fatigue, or distraction. C, roadway design or conditions, and D, weather conditions. Number 2, the emergency response to the crash and fire by local fire departments and law enforcement was adequate and timely. Number 3, the driver failed to control the school bus and prevent the runoff road crash for reasons that cannot be determined from the available information. Number 4, the likely origin of the fire was the exterior of the turbocharger in the engine compartment. Number 5, the blocked exhaust pipe resulting in turbocharger overload with significant heat output during repeated engine acceleration was the primary contributing factor to the initiation of the fire. Number 6, fluids in the engine compartment fueled the fire, but the initial fuel source could not be determined because of the extensive damage to the engine compartment. Number 7, the passenger was possibly attempting to assist the school bus driver whose limited mobility due to medical conditions might have prevented him from evacuating the bus, and she did not perceive the immediate danger before being overcome by smoke and superheated gases as a result of the fire. Number 8, although the school bus driver had progressive chronic pain and stable mild right dorsal flexion leg weakness, there was no evidence that the driver's back pain or leg weakness or other medical conditions and medications, including the drug gabapentin, would have affected his ability to perform the driving functions required, parentheses, while sitting, to operate the school bus. It's likely that the bus driver's progressive chronic back disease, which caused severe chronic pain, impaired his ability to evacuate the school bus himself or to assist the passenger to evacuate. Number 10, the use of physical performance tests on both a routine and an as-needed basis can help identify physically unfit drivers who have a valid medical certificate but who might not be able to perform required safety duties, especially in an emergency. Number 11, the Riverside Community School District exercised poor oversight of driver safety by allowing a driver with known significantly limited mobility to operate a school bus and by not removing a driver from duty who was unable to perform required safety duties. Number 12, awareness training for Iowa School District personnel, including but not limited to bus drivers, transportation directors, supervisors, and superintendents, would increase awareness of the federal and state regulations regarding commercial driver fitness and the avenues available for reporting drivers who have medical conditions that might make it unsafe for them to operate a school bus. Number 13, a fire suppression system in the engine compartment could have prevented the fire from spreading into the passenger compartment. Number 14, the lack of a complete firewall between the school bus engine compartment and the passenger compartment led to the rapid spread of superheated gases, smoke, and fire into the passenger compartment, and the interior components of the bus were flammable when exposed to ignition sources greater than those used in tests under Federal Motor Vehicle Safety Standard 302 and in fire block tests. Number 15, the Oakland fire, along with other school bus fires reported nationally and as shown in school bus fire demonstrations, illustrates that once a school bus compartment is breached, parentheses, even when an exterior fire enters the bus, a fire spreads quickly and smoke, toxic gases, and heat make the interior untenable for occupancy. Number 16, the school bus driver's decision to use the radio to call the bus transportation supervisor instead of activating the 911 emergency button delayed notification to emergency responders. Number 17, emergency training, including training on how to conduct emergency drills with students, is a vital safety exercise that should be incorporated into the annual training curriculum for school bus drivers. And number 18, despite the front-loading door being the often used first means of egress, students might not be trained in how to evacuate through a manually operated loading door if their driver becomes incapacitated.
Great, thank you very much, Ms. Bryson. I understand that there's a few proposed amendments to the findings. I have one from Member Weiner and one from myself. Are there any additional findings that anyone will be proposing at this point? Okay, Member Weiner, I believe you have a motion, or Vice Chairman, you had your hand on the trigger there. Okay, all right. Please.
No, I think I'm going to, excuse me, withdraw that.
Okay, well, that leaves it up to me. So I'd like to offer a new finding, and I'm making a motion that at the appropriate place in the report, insert the following new finding. This, by the way, should be verbatim to what I emailed out last night, but I'll read it. My motion is that we add this new finding. If the Riverside Community School District had adhered to the requirements of its transportation policy regarding the physical abilities of school bus drivers and had not allowed the accident driver to operate a bus until he was medically cleared and fit for duty, or could pass a physical performance test, the fatal outcome of what should have been a survivable run off road, low speed crash might have been avoided. So that is my motion. Is there a second?
Second.
Okay, it's been moved. Member Weiner seconded it. Is there discussion? That verbiage is called out exactly from the text. I didn't invent that text. I'm just trying to elevate it to a finding. Dr. Malloy, what is staff's belief?
Staff has no objections.
Thank you. Any further discussion on this? It's been moved and seconded to adopt this new finding as proposed. All in favor, please signal with a hand and say aye. Aye. Nay, those opposed, there are none. The motion carries unanimously. Are there any additional new findings or any amendments to the findings? Okay, we've just adopted that finding. We need to now go back and adopt the findings as just revised, all of the findings. Is there a motion for such? The Vice Chairman has moved to adopt the findings as amended, as revised, and there's a second. Member Weiner seconded that. Is there any discussion? Seeing none, all in favor of adopting the findings as revised, please signal with a hand and say aye. Opposed, there are none. The findings have been adopted as revised. Ms. Bryson, if you'll please read the proposed probable cause.
Staff proposes the following probable cause. The National Transportation Safety Board determines that the probable cause of the school bus runoff road crash in Oakland, Iowa, was the driver's failure to control the bus, backing it into a roadside ditch for reasons that could not be established. The probable cause of the fire was ignition of a fuel source on the exterior of the engine's turbocharger due to turbocharger overload and heat production resulting from the blockage of the exhaust pipe by the bus's position in the ditch and the driver's attempts to accelerate out of the ditch. Contributing to the severity of the fire was the spread of flames, heat, and toxic gases from the engine into the passenger compartment through an incomplete firewall. Contributing to the severity of injuries resulting from the fire was the poor oversight of the Riverside Community School District in dispatching a driver with a known physical impairment that limited his ability to perform those emergency duties.
Thank you very much. Are there any amendments to the probable cause? I have one. Are there any others? Okay, with that in mind, I'd like to, I'm making a motion to amend the probable cause as follows. And again, for your reference, this is what I emailed last evening. However, this is version 2.1 because after I emailed it out at 5, Member Hamady pointed out that there was the word "the" was missing. So it should be pretty much identical to what you've already seen. But no, it's true, and it was a typo, and I'd rather clear it up now. So what you should have is version 2.1. And so my motion is that we amend the probable cause to read as follows. The National Transportation Safety Board determines that the probable cause of the fatal school bus run off road and fire in Oakland, Iowa was, number one, the driver's failure to control the bus, backing it into a roadside ditch for reasons that could not be determined, and two, the failure of the Riverside Community School District to provide adequate oversight by allowing a driver to operate a school bus with a known physical impairment that limited his ability to perform emergency duties. The probable cause of the fire was ignition of a fuel source on the exterior of the engine's turbocharger due to turbocharger overload and heat production resulting from the blockage of the exhaust pipe by the bus's position in the ditch and the driver's attempts to accelerate out of the ditch. Contributing to the severity of the fire was the spread of flames, heat, and toxic gases from the engine into the passenger compartment through an incomplete firewall. And we're striking the last sentence that was in the original probable cause. So that is my motion.
Mr. Chairman?
Yes.
A point of clarification from
Yeah.
your reading in the document that I at least have in front of me, at the end of subpoint 1, it is typed as to be, could not be established.
Let's see, let me catch up with you. Where are you? I'm sorry.
So let me read the sentence. At point 1 was, number 1, the driver's failure to control the bus, backing into a roadside ditch for reasons that could not be established is what I have typed. What you read was determined.
Thank you.
What is your?
No, and I'm glad you caught that. I want it to read as on the paper there and not as I read. So just exactly as it's in the black and white there, black and white and blue and red. So yes, it should be established. So thank you for catching that. So it's been moved. Is there a second to adopt the probable cause as amended? It's been seconded by the vice chairman. As far as discussion, I'll start out. We clearly established that the school district has the responsibility to provide oversight and keep drivers who should not be driving off the road. As we said, this is not discrimination. This is an issue of keeping medically fit drivers on the road and unfit drivers off of the road. I went and I looked at the SIR that we did last year on select school bus, selective issues in school bus transportation safety, where we looked at 2 crashes. And certainly in each of those crashes, and I'm going to pass this out to my colleagues, in each of those, in the 2 accidents, crashes that we looked at, who did we call out? In the first probable cause for the Baltimore crash, we called out the failure of the schools, the school district, to provide adequate bus driver oversight, allowing medically unfit driver to provide a commercial, we called it out there. And in the second one, the Chattanooga crash, number 2, we called out the Durham School Services failure to provide adequate bus driver oversight. So it is not uncalled for us to call this out. And I think the report very well establishes that the school district failed in their responsibility. And unfortunately, 2 people lost their lives and other lives have been shattered as a result of that failure. So if we're going to just sit around and make a point, we've got to do it. And by putting them in the probable cause, it sends that point that the NTSB is going to call it the way that we see it, and you will be named in the probable cause. And that's an accurate probable cause statement, I believe, the way that I've read it. So there's my thoughts. Further discussion. Dr. Malloy.
Mr. Chairman, we agree that we need to call out the school district for allowing this driver to operate the bus. The way we built the probable cause, and this is different from what we did with the selective issues. In the selective issues, we had bus drivers who their performance caused the crash itself to occur. So one had epilepsy, the other one had just was a reckless driver. In this case, as we set up in the probable cause, We could not determine, could not establish actually, to avoid what just happened. We could not establish why the driver ended up in the ditch. We could not establish why the driver tried to get out of the ditch instead of just calling for help that caused the fire to happen. But we could establish that the driver's physical limitations prevented him from helping the student get off the bus, and that the school district was aware of those limitations. And so we named the school district in the section of the probable cause referring to contributing to the severity of the injuries. So that's basically what staff was trying to do, not to limit, but to focus the physical limitations purely on the injuries and the evacuation.
And I appreciate that. Had the school district prevented that driver from driving that morning, would we have had this same situation?
Likely not.
In fact, we just passed a finding that said if the Riverside Community School District had adhered to the requirements of its transportation policy regarding the physical abilities of school bus drivers and had not allowed the accident driver to operate a bus until he's medically cleared and fit for duty, the fatal outcome of what should have been a survivable run off-road, low-speed crash might have been avoided. So what further discussion do we have?
I think we need to be looking at this concept of driver fitness in its totality. And this is something that we've had some considerable discussion here predates my arrival here on the board. But we see drivers' inability to function in their environment, whether it's motor coach, whether it's truck drivers, or in this unfortunate case, school bus drivers. When you are operating in a safety required position and the fitness levels have been established, then I believe the regulatory authorities and the oversight authorities have the responsibility for holding people accountable. And as you eloquently said, sir, it's not about discrimination. It's about safety of life.
Well, for the 13 years that I've been here, and for the 20 years before that, I've always taken the view of accident causation, that it's too easy to just go out and blame the last person who made the last mistake. We've got to look at the underlying issues, and until we do that, we don't really correct anything. This person, this 74-year-old driver, is no longer here. He's not going to make that same mistake. So we've got to send the message that, by God, if you're a school district, you have a responsibility to make sure that you're providing the oversight that those kids deserve. Any further discussion? It's been moved and seconded. All in favor of adopting the probable cause as amended, please signal with a hand and say aye. Opposed, there's none. The probable cause has been adopted unanimously. Ms. Bryson, if you'd please read the proposed recommendations.
As a result of this investigation, staff proposes 9 new safety recommendations. To the National Highway Traffic Safety Administration, require all new school buses to be equipped with fire suppression systems that at a minimum address engine fires. The second one to them, develop standards for newly manufactured school buses, especially those with engines that extend beyond the firewall, to ensure that no hazardous quantity of gas or flame can pass through the firewall from the engine compartment to the passenger compartment. To the states of Alabama, Alaska, Arkansas, California, Colorado, Connecticut, Delaware, Georgia, Hawaii, Idaho, Illinois, Iowa, Kansas, Louisiana, Maine, Maryland, Michigan, Minnesota, Mississippi, Missouri, Montana, Nebraska, Nevada, New Hampshire, New Jersey, New Mexico, North Carolina, North Dakota, Ohio, Oklahoma, Oregon, Rhode Island, South Dakota, Tennessee, Texas, Utah, Vermont, Washington, Wisconsin, and Wyoming, the Commonwealths of Kentucky, Massachusetts, Pennsylvania, and Virginia, the District of Columbia, and the Territory of Puerto Rico. Revise your school bus driver requirements so that all drivers must pass a physical performance test on hiring and at least annually, and also when a driver's physical condition changes in a manner that could affect his or her ability to physically perform school bus driver duties, including helping passengers evacuate a bus in an emergency. To the state of Iowa, inform your school districts of the circumstances of the Oakland school bus crash and fire and the lessons learned from the investigation, and publicize to your staff the methods available for individually reporting school bus drivers who have medical conditions that might affect their ability to safely operate a school bus. The second, to educate your school districts on the circumstances of the school bus and fire and provide guidelines to drivers on how to present thorough evacuation training to students. Require twice yearly documented school bus evacuation drills, parentheses including showing students how to open a manually operated loading door, and verify that training is available to all potential bus passengers, including students, teachers, and other school district employees who might act as chaperones or school bus drivers. To the National Association of State Directors of Pupil Transportation Services, the National Association for Pupil Transportation, and National School Transportation Association. Recommend that your members verify that students are educated on how to operate the manual release handle for front-loading doors on school buses during evacuation training and drills. To the Riverside Community School District, during your annual school bus driver training, advise drivers on how to use the onboard 911 button in the event of an emergency. To Bluebird Corporation, Collins Industries, Inc., IC Bus, Starcraft Bus, Thomas Built Buses, Inc., and Transtech and VanCon, Inc. As standard equipment on all newly manufactured school buses, install fire suppression systems that at a minimum address engine fires. Ensure that for any opening or penetration of the engine firewall, no hazardous quantity of gas or flame can pass through the firewall from the engine compartment to the passenger compartment in newly manufactured school buses. Those are the new recommendations. We are also proposing some reiterated recommendations. Would you like me to continue with those?
Sorry to make you read so much, but if you would, please.
Oh, sure,
Thank
I'd be
you.
happy to.
Thank you.
As a result of this investigation, staff proposes to reiterate one safety recommendation in section 2.4.4 of this report to the National Highway Traffic Safety Administration. Revise Federal Motor Vehicle Safety Standard 302 to adopt the more rigorous performance standards for interior flammability and smoke emissions characteristics already in use throughout the U.S. Department of Transportation for commercial aviation and rail passenger transportation. And this is a reiteration of H 1512.
Great. Thank you very much for those recommendations. And I believe we have a few amendments here for the, yes, please.
Sorry, sir. We also have reclassified recommendations. You want to do those separate?
Let's do them now, too. Thank you very much for, thank you.
Previously issued recommendation reclassified in this report to the National Association of State Directors of Pupil Transportation Services, the National Association for Transportation, the National School Transportation Association, the American School Bus Council, and Maryland School Bus Contractors Association. Inform your members of the circumstances of the Baltimore school bus crash and lessons learned from the crash investigation to help raise awareness of the avenues available to report school bus drivers with medical conditions that may make it unsafe for them to operate a school bus. This is H 1816. and for the National Association of State Directors of Pupil Transportation Services, the National Association of Pupil Transportation, and the National School Transportation Association, Safety Recommendation 8H1816 is reclassified from open, await response, to closed, acceptable action in Section 2.3.5 of this report.
Thank you, and sorry for the confusion on my part.
And
Thank-
mine as well.
Well, thank you very much. So we have at least two amendments to the recommendations. Member Hamady has two. Do any of our other colleagues have any other? Okay, Member Hamady, the floor is yours.
Thank you. As you mentioned, I have two proposed amendments to the recommendations section. The first would be to add a new recommendation to the National Highway Traffic Safety Administration. I've distributed copies of both amendments. The first one to NHTSA would read, require in-service school buses to be equipped with fire suppression systems that at a minimum address engine fires.
Okay, so that's your motion. Is there a second?
One second.
Vice Chairman has seconded. Discussion.
I'd like to start, if that's okay.
I'm sorry?
I'd like to start on
Absolutely.
the discussion. I recognize that the first recommendation to NHTSA is also for fire suppression systems that at a minimum address engine fires for new school buses. Here's my concern. We've talked about how there is one fire a day on school buses in the United States. We have 26 million children that are transported by school bus every day. And we've established in this report in numerous locations how important installing automatic fire suppression systems are. We've heard from staff about how fire suppression systems would extend the time for passenger and driver egress, and yet we are recommending it installation for only newly manufactured buses. And I'll just read a couple of things from the report, if you don't mind. On page 39, we state that the 2004 Oakland school bus was not equipped with an automatic fire suppression system. On page 78, we state that if it had been, the system most likely would have slowed or stopped the growth and spread of the fire and its progression into the passenger compartment. On page 77, we state enhancements to school bus design, such as installed automatic fire suppression systems, could help prevent crashes and reduce the severity of or eliminate post-crash fires. On page 39, we state the systems can be installed during or just after new manufacture or retrofitted into buses already in service. On page 78, we talk about the Southwest Research Institute testing of currently available fire suppression systems that can be installed in school buses either at the time of manufacturing or in later retrofitting. And then on 79, we have a finding that states the NTSB concludes that a fire suppression system in the engine compartment could have prevented the fire from spreading into the passenger compartment. My concern is the 26 million children that are transported by school bus every day. And so I understand that it's frustrating when a federal agency doesn't move, when there's no will to move on particular recommendations issued by the NTSB, ones that we have recommended time and time again. And I also appreciate the comments that it's unlikely that they may move on that recommendation. Here's where I differ. The NTSB is the gold standard when it comes to safety. Our job is to raise the bar of safety. It's not to meet the other federal agencies where they're at. If they don't want to do it, it's on them to tell us why not, why they won't protect 26 million children that are transported by school bus every day. So I hope that you'll support the amendment and appreciate your time.
Vice Chairman.
It seems to me that, again, I'm just surprised at the number of fires, and I would guess that the problem is more likely to occur in the older vehicles rather than the newer ones because of the maintenance situation and the design considerations. So if we're really going to make a dent, we probably ought to be starting where the fires are, and that's going to be in the older buses. Now, I don't know that we have data to support that, but I would suspect that that sort of makes sense. So I'll stop there, but I think it's a good idea.
Dr. Malloy, what does staff say?
I think I agree with Member Hamady in this one, that the importance of protecting the children, we need to send a clear message. And, you know, I think this is a, with the numbers we're looking at, I think staff is willing to agree with this recommendation. One suggestion I may have is that we potentially make it to the DOT. There are two avenues by which these can be made. NHTSA has a special authority that allows it to do a retrofit recommendation. That's one possible avenue. The FMCSA, through the FMCSRs, has the ability to require operational rules, that if you're operating a certain vehicle, it needs to have certain equipment aboard to be operated. I think that leaving that to the Secretary to decide which is the best approach would be the better approach.
I will agree. I agree with that.
So the friendly amendment, I guess, would be that Member Hamady, instead of making the recommendation to NHTSA, it would be addressed to DOT.
Correct.
Yeah. So I'd like to weigh in on this too. You know, I think Member Hamady makes a great point. The families, they look to us. They look to the NTSB to do the right thing and not try and say, oh, that would be too expensive or that's not practical. People look to the NTSB to set that bar high. And many of us, I wasn't around, but 21 years ago, TWA 800, no, 20, well, I can't even do it, 1996? How long ago was that, 23 years ago? You know, the NTSB came out with a recommendation for fuel tank flammability standards. And everybody said, oh, no, that could never be done in airplanes. And then you know what? Because we set that bar, because we came out with that, people said, you know what, we can do that and we will do that. And the FAA required it, not only for forward fit airplanes, for airplanes rolling off the production line, but they put a retrofit provision in there as well. And yeah, it was phased in over time. But that's what we have to do. We have to raise the bar. Is there any other discussion on this motion?
I might just comment that, as we found in aviation, if you don't do retrofits, it takes a long time to incorporate a safety recommendation or a new system. So I would see this as being the best way to get the most performance from a safety perspective.
Wonderful. Any further discussion? Thank you for your motion. It's been moved and seconded to issue a recommendation to the DOT. The motion was read by Member Hamady. There's no further discussion. All in favor, please signal with a hand and say aye. Opposed, there are none. The motion passes unanimously. Member Hamady.
I'm going to withdraw my second amendment.
Okay.
Thank you very much to the staff for working with me on the First Amendment. Thank you.
Thank you. We've adopted a new recommendation. Now let's go back and adopt the recommendations as amended. Is there a motion to adopt the recommendations as amended? It's been moved by Member Weiner, seconded by the Vice Chairman. Any discussion? Seeing none, All in favor of adopting the recommendations as amended, please signal with a hand and say aye. Opposed, there are none. The recommendation have been adopted unanimously. Does anyone have any additional issues for discussion concerning this report? Okay, I'd like to entertain a motion to adopt the report as revised. It's been moved by the Vice Chairman, seconded by Member Weiner. Motion's been moved and seconded. Those in favor of adopting the report as revised, please signal with a hand and say aye. Opposed, there are none. The report has been adopted unanimously as we just revised it just now. Do any members wish the right to file a concurring or a dissenting statement? I do. Member Weiner? Two of us do. I will talk about the responsibility of oversight of school districts in doing their jobs. Any further discussion? Well, thank you. Thank you to the staff for your hard work. Thanks for my colleagues, too, for preparing for the meeting with staff individually, for studying the report, learning the issues, and being prepared for this meeting. Pete Katowski, I want to thank you for your leadership as the IIC. Michelle Beckjord, you're the cat herder, I think. Keeps it all running. I want to thank you all, but I've always said this ever since I've been the chairman, nothing ever gets done by just one person. It takes an entire team. It takes the investigative team, but nothing around here gets done without the support staff and the program staff. And so, good work, guys. Thank you. Today's new and reiterated recommendations, if acted upon, will result in fire safety improvements in new school buses for the first time in decades. Let me repeat that. If these recommendations are acted upon, it will result in fire safety improvements in new school buses for the first time in decades, since 1971. They will also result in regular physical performance testing of drivers, and they will result in improved reporting of school bus drivers who are not fit for duty. Driver oversight looks hard-hearted. It looks like a workplace that refuses to make exceptions from physical performance testing, even if the driver is so physically impaired that he could not possibly pass such a test. But that's the point. Safety is a professional driver's job. If a driver cannot play his or her role in an emergency, that driver has to be relieved of duty, at least until the medical condition is resolved. A lot of papers here. School district administrators, let me ask you this. If this tragedy happened in your school district, wouldn't you act to ensure your drivers were medically fit? We know there's a shortage of school bus drivers, but the solution cannot be to augment the ranks of safe drivers with drivers who are unsafe due to a medical condition, even a temporary one. Keeping an unfit driver on the road, it isn't kindness. Once there's a crash, it is cruelty to him and to an untold number of passengers and families and other road users. I'm going to officially adjourn the meeting, the business part of the meeting, but I'd like to everyone to just stay seated so I can talk about a colleague of ours who will be leaving soon. This is Member Earl Wayner's last board meeting. Earl has been on the board for 9 years. June 30th, he was sworn in 2010. It was August of 2009 when I got a call from a high-ranking official that said, we have an opening on the board. Do you know anybody that would be good? And I said, yes, I do. And that guy never made it. No, it was Earl. It was Earl. Of course, I gave him your name, and here you are, and it's been a pleasure to work with you. I've known Earl for over 25 years. Earl was at Boeing for almost 2.5 decades, and in your early applications, you were one of the early appliers of safety data. You and your team came up with the notion that if the number of airplanes keeps increasing and the accident rate doesn't go down, it's just simple math. You have a number of airplanes that's increasing, but a rate that stays the same. We're going to double the number of accidents that we have worldwide. We'll be having about one aircraft accident each year, one aircraft accident each week in this world. And I think you came up with that, and that brought the pressure to bear on what became the Gore Commission, chaired by then Vice President Al Gore, which led to the Civil Aviation Safety Team, Commercial Aviation Safety Team, which really has surpassed its goals. They were established in '97. They set a worldwide goal to reduce aircraft fatalities commercial fatalities by 80% over the next decade. They surpassed that goal. That work started with you, Earl. But we're not here to talk about your work at Boeing. We're here to talk about your work at the board. Actually, we are here to talk about it all. You've not just been multimodal. Certainly, Member Weiner has an aviation background. And you brought that to the General Aviation Joint Steering Committee. To the CAST, which you have attended on a regular basis and participated in. You brought light to loss of control in general aviation and how almost half of the fatalities in general aviation are because of loss of control and work that can be done there. I don't know how many weekend seminars you've conducted out at the training center to highlight general aviation safety, but I think it's been in the double digits, I believe. But it's not just aviation. Earl brought his Marine background as well. I also believe you were the one that came up in a board meeting on the notion for SMS, safety management systems, in rail. I think you were the one that offered that recommendation. Now everybody is clamoring for safety management systems in rail. Today, you bring your expertise to the board as it relates to highway, as you have for pipeline and transportation of hazardous materials. So really, Earl, you have been the real thing for an NTSB board member, and I've enjoyed learning from you. I've enjoyed being a colleague of yours, and I wish you and Linda, I'm glad you could make the board meeting. I wish you and the two doggies Godspeed and good wishes, and thank you. My colleagues, is there anything you'd like to say? I know you've been on.
Well, Bruce and I are the newest of the team, but Earl, before I came to the NTSB working on Capitol Hill, I used to log on and watch all the board meetings by computer, including all the important issues you brought up in each of the board meetings and the board hearings. And I wish we had more time together because you did a lot of great things for safety while you were here at the board, and thank you very much. And I also will never forget you coming to my Senate confirmation hearing, and I really appreciated that. Thank you.
And I'd like to chime in as the General Aviation Joint Steering Committee co-chair for way too many years. I had the real pleasure and honor to have you join us on a regular basis at those meetings, and generally you sat quietly, except occasionally when you couldn't help yourself, and then you would talk to us about the things that we really needed to be working on. I will also say that I just made the incorrect observation that when you were new to the board, and I have since learned differently, but when you were new to the board, you seemed to pretty much always get the bus accidents, and that seemed appropriate for an aviator. But the last point I'd like to make is, as a pilot and somebody who has great appreciation for the engineering of the machinery that we get to fly, your whole concept of simpler being safer is absolutely on the mark, and I wish we had more people who thought like that. So thank you for the opportunity to serve with you.
I agree. Sir?
Well, to be honest with you, I'm a little overwhelmed by your comments, and thank you very much. No long speeches, but the value of looking at data to identify where the hurt is, and then go work on those, and don't get distracted by the small ones, but keep the focus on the big ones. And the second point is collaboration. The industry working together as a community, the regulators, the manufacturers, the operators, there's where the real power is. If you can get all of them pointed in the same direction, driven by data, great things happen. I've certainly enjoyed my 9 years at the board. I'm also looking forward to a little off time. And thank you for the opportunity.
Thank you. You sure are entitled to a little off time. Thank you. We stand adjourned. Thank you.